Okay, in theory of machine, module 4 cams, we are going to see the types of the cams now. So this point onward, we are discussing the different types of cams and how we are going to look at them. So the cam can be of different, can be classified in different terms. For example, in terms of the shape, in terms of the follower movement, in terms of the manner of constraint of the follower. So basically our discussion will be on the first two things, the shape and the follower movement, because as we said that we are not very much interested in the frame itself, so we are more concerned with the shape and follower. And during our discussion you will see that the manner of constraint can also be seen in our discussion. Okay, so the first type is wedge and flat cams. So you can see it over here. This is a straight line. Basically this is the cam, this is the follower, and this is the frame, the guide, which is allowing it to move in a specific direction. So this cam can move right and left, okay, and there is a straight line over here. This can push it up and down. The follower can go up and down. Because of the straight line, as we move right or left, it can go up and down according to that height. If you want to have a non-linear relationship between the follower and the cam, so you can see this one, the cam itself, this time the profile is non-linear, not a straight line, but some form of curve. So you can see the curve over here. The cam can move right and left, and it can push the follower in a specific direction. Because of this specific frame condition, we do not have any rotation allowed over here. We only have one rotation on this side, so it will move up and down in a circular manner. The spring is attached that makes sure that there is a mechanical contact with the cam. This follower has a kind of a roller attached to it. Another example is this cam. This can move right and left, and there is a small wedge available over here, or you can say a small slit. This will allow the roller to move when the cam will move right and left. So when the cam will move on the left, this part will be over here, so which allow the follower to move upward. When the cam will move on the right, so this lower part will be in the middle of over here. Okay, so this allow the follower to go down. So you can see this follower can go up and down while the cam can move right and left. Another type is the radial or disc cam. So you can see it over here. This is the cam profile. So you can see it over here. It's a non-circular. It is more like an oval shape. This is the point of contact or the center point of it. This is basically eccentric, which means it's not connected with the center of this profile, but away from the center, away from the centroid of it. These are the guides, and we have a follower. Again, you can see that the spring is attached, which makes sure that it will remain in contact with the cam profile. Once the cam will move, if the cam will move in this direction, clockwise direction, then this lower part will come on this side, which allow the follower to go down. Once this part will move up on this point, so you can see this larger diameter will come over here, and this will force the follower to move up. Similarly, this is the frame attached with the follower, guides, and the cam itself. This cam is the disc cam. However, it is connected eccentric, away from the center, little bit away from the center at the point of rotation. So the point of rotation is not the center of the disc, but away from the center of disc. In this frame, you can see that there is some space available. When this disc will move, it will push, when it will move, for example, clockwise, it will push this whole frame or follower downward. When this point will come over here, this whole thing, whole follower will go down. Once we'll go back on this side, the whole follower will move up. So this whole frame can move up and down. And as you can see that there is a space on the right and left, this cam can freely move in all the dimensions available over here, all the space available over here. Then we have this spiral cam. In this spiral cam, you can see the cam is connected. The cam is connected in the center of it. However, there is a groove on this cam. This groove is spiral shape and it allows the follower to move in a specific speed depending where your follower is touching the mechanical contact with the cam in the groove. Then we have a cylindrical cam. So you can see that there is a cylinder and there is a groove in the cylinder. The cylinder can rotate about its axis. As you can see it over here, it can rotate about its axis. Once it will rotate, the cam will allow the follower contact point to move at different level, and because of this the follower will move right and left, as we can see in this arrow. And because of the groove, the speed at which it will move right and left will be totally different all the time. Then we have a conjugate cam. So in this you can see that there are two cams attached with it. There is this disc number 2 and this is disc number 1. This will allow this follower to move right and left, right and left. So it's like a switch on, switch off kind of a situation over here. Once this disc will move upward, it will switch this on. Once it will move downward, it will switch this. So this follower, it can be attached with any of the electrical circuit to make it on and off and perform the specific function. The follower can be in a position once it will touch the disc 1 or disc 2 of the cam. Then we have this globoidal cam. So this is nothing, just another form of cylindrical cam. So in a cylindrical cam we have a straight line. So I quickly go back to show you that this is a straight line over here because it is a cylinder. Rather than a straight line over here, this cylinder have like either bulge out or bulge in. Okay, so it will be convex surface or concave surface, and rest of the mechanism is same. The groove and the follower will move accordingly. Then we have a spherical cam. So in a spherical cam, it's like a sphere attached with it, and there is a groove on the sphere. This groove is not exactly on the diameter of it. If it is on the diameter, it will rotate in the same manner. It is away from the diameter. You can see it on the top. It is close to the center, and once it go to the bottom, it's away from the center. So you can see it over here. So this follower which is attached, the rotation is allowed over here. The spring is just to make sure that there is a mechanical contact. So this follower, depending upon which point of the spherical cam it's touching, it can go up and down on different orientation. This sphere can be attached at the center point or away from the center point. Okay, now we are going to see the follower movement, how the follower will follow the movement when the cam is rotating. So there are two main things. One is called dwell and other is kind of a motion, non-dwell thing, you can say rise and return, or we can use some other terminology for it. So what does dwell mean? Period with no output motion with input motion, which means that even the cam is moving but the follower is not moving. That is a dwell. And the non-dual condition is rise and return, return and rise, and so on and so forth. There different scenarios are possible. Think about using a crank and rocker mechanism. Okay, so there will be no dual in it. So let's look at these 4 graphs, and we are going to discuss each of it in detail. These graphs are having, on x-axis is a cam angle from 0 to 360 degrees, which means that it is showing the one complete rotation of the cam. One complete rotation of the cam, rest of the cam will follow, the motion will repeat itself, it start repeating itself. On y-axis we have a follower displacement. So in figure A you can see the moment the cam is start rotating, so it will be rise. Rise means that because we don't know the profile, exact profile of this cam, but from this graph we can predict that from the center the diameter is increasing, that force the cam to move upward or away from it until it's reached to the point, the maximum point at certain angle. We don't know the exact angle from this graph, but we can find out the exact angle of this graph. Once it reached to the maximum point, then it is returning back and reached to the 360 degrees. One complete rotation happened. If you look at the B, so you can see that there is a dual, which means the cam is still moving because the angle is increasing, but the follower is not moving at all. There is no displacement in the follower in y direction. At some point, some angle, this is start going to move upward, or you can say the diameter of the cam is increased. Because of this, it is forcing the follower to rise. At certain angle, it reaches to the maximum value and then return back. This is the one complete rotation of the cam. If this cam is keep on moving, then again there is a dual, then rise, then return, then again there is a small portion of the dual, then and so on. This will keep on repeating itself. Figure C, you can see that there is a dual period, then there is a rise, and you reach to the follower reach to a certain point, and after that there is a dual again, which means that the follower, whatever the displacement position it reaches, it will stay there, although the angle is increasing, which means that the cam is still rotating. So the diameter of the cam is not changed at this point, and after that it will return back to its position. So which means that over here the dual, and this point the diameter of the cam from the center of rotation is not changing. So the follower is not either going up, not going down. It's dual, it stays at its position. The fourth graph is also showing that there is a dual. After that there is a rise. Once it reaches to the maximum position, there is a dual again, and then suddenly fall down. So you can see this not a very good graph, but it can explain you this kind of a situation. That once it is moving, it will reach to the point. Okay, so there may be a dual period in the start where the diameter is same, and then after that it's increasing, and it reach to the, because if you look at the distance from the center is increasing. Okay, so if you look at the distance from the center, it is increasing, which means that it will pushing it up. Once it reaches to the point, and then suddenly there is a fall. So it will come back to its base position, or you can say the initial position. It will create a sudden jerk, but beside that, this is how this graph can be explained. So we have a different situation. So we can talk about the multiple scenarios, and these scenarios are rise and return, or you can say the dual rise, dual, and so on and so forth. So there are multiple scenarios are possible in these